Okay, so in this example here, we have an integral of dx over 25 plus 9x squared. So immediately we see that sum of the squares being added, x squared being added. So we know that that's going to be a tangent. X equals a tangent theta. But here it's 25. So a is of course 5. But it's not just x squared, it's 9x squared. So the substitution would actually be 3x equals 5 tangent theta. Okay. So of course, later on when we solve for tangent theta, we'll have to divide by 5. And when we're solving for the dx, we'll have to divide by 3. Those are things we're just going to have to kind of keep in mind here. So we do the substitution. 3x is going to replace 5 tangent theta. So we differentiate. 3dx is going to be 5 derivative of tangent, secant squared, d theta. And so dx is actually going to need to be 5/3 secant squared theta, d theta. Okay, and so we make the change. We make all those changes here now. This will be the integral of 1 over the square root. And when we make the change, 3x becomes 5 tangent. That's going to be 5 tangent squared. Right? The whole 9x squared is 3x quantity squared. That's going to become 5 squared tangent squared. So we're going to have 25 plus 25 tangent squared. And then we have 5/3 secant squared theta d theta. But we know that the 25 can be taken out. We'll have 25 times 1 plus tangent squared. But we know 1 plus tangent squared is secant squared. So we're going to have square root of 25 secant squared. But that's just going to be 5 secant theta. Okay, so putting all that stuff together, we're going to have, well, first let me take the 1/3 out. I'm going to keep the 5 because I want that 5 to cancel with this 5. All right, so I'm just going to leave it so it cancels. And then the 1/3 will be sitting out front. And I'm going to have integral on top of 5 secant squared theta over 5 secant theta d theta. So of course the secant cancels, and we just have 1/3 the integral of secant theta d theta. We remember that though to be the ln of the absolute value of secant theta plus tangent theta plus a constant. And so now at this point we have done all the work we need to do to have worked out the integral. Now we just need to go backwards now. And again, the key here was we had a squared plus x squared format. So we did the x equals a tangent theta, or in this case 3x equals 5 tangent theta. That lets us solve for dx, which we substituted in. And of course that transforms this to a 25 plus 25 tangent squared. Pull out the 25 and use our trig substitution. We get 5 secant theta, which will cancel with the 5 secant squared. Of course, the 1/3 I left out front left us then with an integral of secant, which we know is 1/3 the natural log of secant plus tangent. Okay, at this point now we go back to this condition and try to compute secant and tangent. So we once again use the trig definition here. Let me rewrite this. 3x over 5 equals tangent theta. So we draw the picture. And again, tangent, as far as its inverse is concerned, is tied to the first or fourth quadrants. So when I draw the picture, I want to draw it in either the first or fourth quadrant. So we'll put it here into the first. There's my theta. Tangent is 3x over 5, so that is opposite over adjacent. And remember, we use Pythagorean theorem to find the third side, which would be the square root of the sum of the squares, or square root of 25 plus 9x squared. All right, and then we come to our problem here, and we compute our secants and tangents. So 1/3 ln secant is going to be the hypotenuse over the adjacent. So square root of 25 plus 9x squared, all that over 5. Okay. And then tangent will be 3x over 5. That's all inside the absolute value. Now, that answer's fine. Okay? That answer is absolutely fine. However, do not be surprised if when you look this up or follow along with a textbook, that they don't do something like this and drop out that 5 from the ln. Because ln of a product is ln of the first plus ln of the second. So you have ln of 1/5. ln of 1/5 is a constant. So they may just totally drop it out of the problem, kind of show off their knowledge, and just say plus c. Now, technically, it's a different c than this one, but usually you just write plus c anyway. All right, and that's because the 1/5 and the property of logarithms. Right, log of a product is, that would be ln 1/5. ln 1/5 is some number. So when you add that onto the c, you just get some other number. So we can actually eliminate it from the integral. You may see that happen. You may see that happen in an example like that, or maybe it won't. But it's definitely something that could happen. It's definitely something that has that potential to happen. Okay, so here's an integral again that uses a tangent substitution. A little bit more to it because it wasn't just 1 or x squared, right? So we had to do a little adjusting of things, but everything for the most part flows pretty straightforwardly. And then the second part of that, finishing it off, is using your trig function definition, right, to be able to compute the other pieces.